everyone, welcome back to Building Apps with Mr. 636. This is the second installment of Learning Python Basics using Turtle. In this video, we are going to discuss in greater detail all the different methods that Turtle offers us for moving our turtle. Like before, we're going to start by importing Turtle into our project by saying from Turtle import star, or in other words, import everything. Now, as we already covered in the previous video, we already know some of the more basic movement commands, such as forward, backwards, right, and left. We also know that we have shorthands for each of these commands. With forward and backwards, when we enter a number, we're referring to the amount of pixels we want to move, and right and left, we're referring to the amount of degrees that we want Turtle to rotate. If we go ahead and hit play, we can see that the screen opens and closes extremely fast. So we want to include done with parentheses at the end. This will keep the screen open so we can better see what we have done. Another method that we haven't discussed is the home method. This is going to return the turtle back to the point of origin, which is also 0 on the x-axis and 0 on the y-axis. We also have another new method that we'll talk about, which is clear screen. This is going to remove everything that we have drawn with Turtle up to this point. And I'm just going to throw a note right here declaring that these are more or less your more basic movements with Turtle. Next, let's talk about setting our position. Setting position is a way that we can place our turtle where we want on the screen or on the window using XY coordinates. We can see here that we can pass in a tuple of two floats. Float is a data type. We won't get into too much detail on that right now. For now, we're just going to pass in whole numbers. Now, when they say a tuple, what they're referring to is a list of values inside parentheses. So if we pass in 80, 80, what we're saying is we want Turtle to move to 80 on the x-axis and 80 on the y-axis. We also could pass in just two different values without a tuple, and it'll work exactly the same. Just note that we dropped an extra set of parentheses. We have another option, which is set position or set pos. They work exactly the same, and they both also work exactly the same as go to. So we can see we just moved backwards 160 pixels total, because we want negative 80. We also have the option to use set X and set Y, where we will set these values independently. So we will say set X equals 0 and set Y to 0. This is ultimately going to return the turtle to the point of origin, just one step at a time. Or I should have said one axis at a time. The next thing that we will discuss is setting heading. So when we set heading, what we are saying is we want the turtle to rotate from its original direction a certain amount of degrees. The best way to look at it is at 0 degrees, the turtle will always be facing towards the left, or in this case, the east. So when we say set heading equal to 90, we want the turtle to rotate 90 degrees from its original direction of looking, which would be again from the east. We can see this a little bit better. Of course, there is a shorthand, it's called set H. We can see this a little bit better if we say set H equals 270, which is more or less telling Turtle to look 180 degrees past 90. So I'm just going to add some notes here to help us keep track of what each direction each degree is going to be facing. 0 being east, 90 being north, 80 being west, and 270 being south. No matter what direction turtle is facing at the time, when you say set heading and use any of these degrees, it will always look in that direction. Of course, we are not limited to just those 4 options. We can plug in basically any number between 0 and 360. So again, if we look, we see that 299 only rotates the turtle a little bit. So that way, instead of facing south, in a sense, it's facing southeast south. The next method that we are going to discuss is the circle method. This is basically just going to tell Turtle to draw a circle. So if we see the first argument, we have 3 options that we could pass in, or 3 values that we can pass in into this method. One is expected and the other 2 can be none. The first one should be a float value and or a number with decimals, but for now we'll just use a whole number. This number is going to represent the radius of the circle. So when we run our program, we can see that Turtle draws a circle. The diameter of this circle is actually equal to 200, considering that the radius is equal to 100. The next option is extent, which again is supposed to be a float or a whole number. What this does is it will draw part of a circle to the amount of degrees that we put in for our second value. 180 being half of 360, the turtle drew half a circle. Same thing with 270, the turtle will draw 3/4 of a circle, as we can see here. Now, in order to get the third parameter or the third value to work, we have to have all 3 values or the 2 previous values. So for us to be able to make use of the steps argument or the steps value, we have to basically include the radius and the extent. What steps is going to do is it's going to put sides to our circle. In this case, we can see that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. This is useful for if you want to draw something like an octagon or a pentagon. You could just simply call circle, the size of the circle, 360 degrees, and the number of sides that you want. To help better demonstrate circle, I'm just going to include a couple of examples, so that way that'll be here in source code later on when you want to work with this yourself. Our first circle is going to be a circle with a radius of 200 pixels. Our second circle is going to be half a circle with a radius of 112 pixels. The turtle will then go home and draw the final circle, which will actually be a pentagon. Finally, we clear the screen so we can go into our next method. Our next method will be the dot method. So essentially what we're going to be doing here is along the way, whenever we call dot, the turtle will leave a dot on the screen of a specific size and or color. It is required that we give it one value, a value of a whole number, and it's not required, but we can give it a second value, which will be a color inside of quotations. What we'll see here is when the turtle places this dot, it's a green dot with pixel radius or a pixel diameter of 15 pixels. Real quick, I'm just going to draw a couple of lines, have the turtle make a right hand turn, and just place a couple of random dots with random colors that are random sizes. So we can see the turtle drew 3 dots, one red, one blue, one green, all different sizes. We'll go ahead and clear the screen and move on to our next method. Next method that we'll discuss is the stamp method. Like dot, when called, it's going to leave a shape on the screen. Unlike dot though, instead of leaving a circle, what it's going to leave is an actual shape of the turtle. First, just to help illustrate what's going on, we'll draw a basic square. We can see that there's nothing special about this square. So let's pass in stamp in a few random places, or actually on each corner. Stamp doesn't take any arguments. So now this time when the turtle makes its round around the square, you'll see on every corner it's going to leave, in a sense, an imprint of itself on the window. To help us see that last stamp, let's just say forward 50 so that way the turtle moves off of the last stamp. We have another method called clear stamp, and what this is going to take is an integer. How do we get this integer? Well, whenever we call stamp, not only is it leaving the shape of the turtle in its current location, but it's actually returning a value of the absolute position that the turtle currently is in. That absolute value is a whole number or an integer. We'll get more into what an integer is later. Built into Python, we have what's called a print statement. This is a tool that can be used to help us debug or find out what values we are working with. We could pass in any type of data structure or data type or value, and it'll print it to the console down here. So when the turtle made its first stamp, you could see that it gave us a value of 28. So inside this clear stamp method, if we pass in the value of 28, what it's going to do is it's going to clear the first stamp that the turtle makes. There you can see that the very first stamp is now gone. We also have another method that we can use, which is called clear stamps. And we have a couple of options of how we can work with this. So if we just leave it empty, what we'll see is all the stamps that the turtle creates will be removed. We can also put in a number. This number will be basically what it does will be determined whether it's a positive number or a negative number. In this case, the positive number of 2, you can see that it removes the first 2 stamps that the turtle created. If we call the same thing and give it a value of negative 2, it'll remove the last 2 stamps that the turtle creates. Like so. The next method we'll discuss is undo. This is pretty simple. All we need to really do is call undo, and it'll undo the last move that the turtle made. So right now we can see that the last thing turtle does is move forward 50 pixels. What we'll see the turtle do is move back that 50 pixels back to the corner. To help better visualize what is actually going on, let's just go ahead and copy this line a couple of times. So basically what turtle will do is move forward, then move back, unstamp, unrotate, move back, and unstamp one last time. Of course, the last stamp you really don't get to see. last method that we're going to discuss for the movement section is speed. I'm going to go ahead and include a couple of notes real quick. Speed is going to take in a number, 0 through 10. And yes, I mean speed, not speed. 1 will be the slowest, and it'll increase as the number increases. The speed will increase as the number increases. So, to reiterate, 1 is going to be the slowest, and as the number increases, so will the turtle's speed. And when I say speed, I'm talking about the speed at which turtle will draw the pattern. 2 more notes to take in is that 0 actually is the fastest setting. And if we actually pass in a value that is less than 1 and or greater than 10, 0 is going to be implied and is going to default to 0, or the fastest speed setting. We can also pass in an actual word inside of quotations. The word options that we have available to us is going to be slowest, slow, normal, fast, and fastest. So you can clearly see already that we have more options available to us if we use a whole number value rather than a word value. Let's go over a couple quick examples. And well, let's first clear the screen of our last pattern. So to start, let's go ahead and set our speed to be equal to 1, which is the slowest setting. We'll tell the turtle to move forward 100 paces or 100 pixels, and then have turtle move backwards 100 pixels. Next we'll say speed equals normal, which is going to be the default setting, which is what turtle has been operating at this whole time. Again, we'll say right 30 degrees, forward 100 pixels, and then backwards 100 pixels. Last thing we'll test out is turtle at full speed, or 0. We'll have turtle draw a circle with a radius of 100 pixels. We'll have turtle turn right 2 degrees, and then have turtle draw another circle with a radius again of 100 pixels. We'll copy this one more time. Now when we run this, you'll almost not even notice the turtle draw the circles because of how incredibly fast it actually is. But you can see it moves forward and backwards pretty slow, draws that one line pretty quick, and then draws all 3 of those circles, and it almost record speeds. And that's going to basically conclude this video on movement with turtle. So if you liked this video, found this video helpful, or you just feel like supporting my channel, please feel free to drop a comment below, like the video, or even subscribe to my channel. Until next time, happy coding.